I'm Mr. Sand, and I'm going to walk you through a couple of the warm-up problems for Newton's third law. So Newton's third law is a reaction has an equal and opposite reaction. So in this little diagram right here, you see all these arrows that are pointing up and pointing down. These arrows, all I want you to do is I just want you to write the force. So for instance, you could just say, let's see here. I want to annotate this. How do I annotate this? Ooh, tools. I'll figure it out in a second. Nope, not that. Okay, well I can't seem to figure out how to annotate this right now. But let's just say that this is, let's take the example of these two arrows right here. The force right here is the force on the Earth due to the table. There's some gravitational force. The table's pulling the Earth, just like this is a huge table right here. The table is pulling the Earth, just like the Earth is pulling down on the table. They interact with each other. So for every force, there's an equal and opposite force that's pulling back. Now, this is not going to move the Earth too much if the Earth is really big compared to the table. In this little drawing right here, the table is pretty big compared with the Earth. Here you can see, let's look at this. Let's look at these two little pairs right here. This little force right here being pulled down, this is the force on the cup, so it'd be the Fc due to what? Due to the Earth. So it'd be you call it Fce. Those are the two subscripts, the C and the E. And over here, this would be the force of the Earth due to the cup. Okay, so you're just going to write these little interaction pairs right here. All right, so that's all I want you to write down here. All of these are going to be involved with the Earth pulling down on it and the objects pulling the Earth. Okay, so the difficult one, I think, in my mind, is the one right below it. You've got this little person who is about to fall into the water. The question is, why does she fall into the water? Okay, well, let's see if we can. Let's not save that. Okay, let's see if we can figure this one out. So she is. I'm going to just redraw this whole situation right here. So you've got the little canoe, you've got the water, and you've got the person who's about to step off, and she is. She's in trouble. Okay? She's in trouble. Why is she in trouble? She's in trouble because as she pushes, she's pushing this, right? She's pushing this boat. The boat she's pushing in that direction. Okay, there's a force. So this is the force on the boat due to, let's just call this woman. So BW. Force BW. That's the force on the boat due to the woman. Now the force on the woman due to the boat is going to be equal and opposite, right? Right. Okay, so the force on the woman due to the boat, that's going to be equal and opposite. Now, this is normally fine if the boat is stationary, if the boat is anchored to something, right? Let's say that it's got super high friction right here. If it has super high friction, then woo, she is going to be pushing off and she's going to be propelling forward. Okay? But in this case, you got something special. In this case, you've got water, and that's this stuff right here. This water has a very low friction compared to something like grass or dirt or something else that the boat would maybe be stuck in that wouldn't move very easily. So since this has very low friction here, that makes this boat simply slide out from underneath her. And because it's not anchored anywhere, she just drops straight down. That's what is going to happen because these forces are just going to cancel each other out. The boat moves in that direction, very low friction. She might move a little bit forward because friction right here, you could draw another interaction pair. The boat, let's draw another interaction pair down here just to make it very clear. Down below, the interaction between the water and the boat. So the force on the water due to the boat and the force on the boat due to the water. Okay, you got another interaction pair down here between the surface. Okay, but there is no friction. There is no friction that is going to be opposing the force of the water due to the boat. So this is simply going to be sliding out here, and there's nothing going to be opposing it at all. So this overall force is just going to be sliding out, and overall everything cancels out, and she's just going to drop straight down. The boat's going to go this way. She's going to go this way. Well, she's not going to go that way. The boat's going to go this way, and she's going to fall straight down because there's no friction that's opposing her from the surface of the water in the boat. Okay, I hope that makes sense. That's really all I wanted to say about the warm-ups. I hope that helps, and good luck.